Okay, any doubt in this array-based queue representation?
No, ma'am.
Any doubt? What is queue? What are all the operations we are performing? Any doubt? And for tomorrow's class, Saturday's class will be pre-recorded class, will be uploaded in the Google Classroom. So tomorrow you can attend the pre-recorded class as per the instruction from academic dean. I think you people are maybe traveling from your hometown to the hostel. So as per the instruction of dean academics, today's 28, 29 and 30th class. What is 30th? Sunday. 28 to 30th classes should be recorded and it should be uploaded. Okay, you got the idea? So tomorrow I will upload your tomorrow's class video lectures in Google Classroom. You please listen to that. Maybe while traveling you may face some network issue. To avoid that, tomorrow's class you can attend through video recorded classes from Zoom Classroom. Sorry, from Google Classroom. Any doubt in the representation? The screen is visible.
Yes, ma'am.
Yes, you take the queue, how we can represent the queue in C or C++. What is the logic behind the algorithm means? Queue is a data structure in which the elements are added at one end called the rear and the deleted from the other end called the front. So the queue will look like this. So it's like the stack is like a container. It's having only one way to push and pop. But if you take the queue, it's a two-way. We are deleting from the front side. The first person who is entered in the queue will be deleted first. First in, first out. No? So the first person who is entering, waiting for the in the airport, we will be waiting for departure and arrival. Na? Get in. That is gate number. We will be waiting. So for departure, So the person will be standing in queue, they will allow you as per the zone and the zone 1, zone 2, like that. So the person who is standing first in the queue will be entering into the flight first through the queue. Front is the front side of the queue. The first person who is standing in the queue will exit from the queue from through the front. The person who is coming and joining the queue in the back end will be the through rear or the back side. We are adding the elements through front. We are deleting or exiting from the queue. The first in first out data structure is called queue. The FIFO. The rear of the queue is accessed whenever a new element is added to the queue, and the front of the queue is accessed whenever an element is deleted from the queue. If you want to delete the element from the queue, you will access through the front. If you want to add elements to the queue, you will access through the rear. In a stack, the middle element of the queue is or accessible even if the queue elements are stored in the array. If you are storing the elements in an array form, even the middle element also we can access. The basic queue operations are initialize the queue. First, we need to create the queue to perform the various queue operations. So, initialize queue. Then we have to check whether the queue is empty. If the queue is empty, then we need to add elements to perform other operations. Determine whether the queue is empty. If the queue is empty, it returns the value true. Otherwise, it returns the value false. Determine whether the queue is full. If the queue is empty, it returns the value true. Otherwise, it returns the value false. Rear is a pointer used in the queue. Rear returns the last element in the queue. Prior to this operation, the queue must exist. Queue should be created. Then through the rear, we can add element into the queue. And to delete the element from the queue, we are using front pointer. Through front, we are deleting the element from the queue. Returns the front, that is the first element of the queue. Prior to the priority to this operation, the queue should be existing. First, we need to create a queue. If the queue is created and the top front and rear is initialized, then only we can perform addition through the rear and deletion through the front. Queue can be stored either in an array or linked list form. So we can represent the queue using two forms, array form and in linked list form. We will consider both the implementations because if elements are added at one end and removed from the other end. We need two pointers to keep track of the front and rear of the queue. So we need two pointers, front and rear, to keep track of the operations. Q front and Q rear are the two pointers we are using to perform the addition and deletion. Qs are restricted versions of array and linked list. The queue is a special version of arrays as well as linked list. So the queue will look like this. We have a collection of memory location. First, we are creating a queue and we are adding elements into the queue. Adding of elements is done through the rear backside. And once the elements are added, we can delete the elements through the front. Adding of elements into the queue is called NQ. Deletion of elements from the queue is called DQ. And it is first in first out data structure. The first one, the data what we put into this queue will be deleted first. How we can represent the queue using abstract data type in C++ means we are including the header file std.lib.h, include iostream.h, using namespace std, define maximum size of 5. So it means we are giving minimum, we can store minimum 5 values into the queue. Here also we are using a template class Q. It is of template type, template keyword followed by class T. So the class is of T type, so it can accept T-type variables. The variables in the queue will be of T-type. We are having the private variables T-type, maximum, queue of maximum. So maximum is the number of elements in the queue, and item is the value what we are going to add into the queue. And we are using two more pointers of integer type, front and rear. Public queue. Queue is an, our class name is queue and the function name is queue. So it is a constructor function. When the constructor is called, whenever we initialize object, the constructor will be automatically executed. That will initialize the variables queue of maximum, an array, and item, and the two index variable front and rear. All the variables will be created, and the initial memory space will be allotted for all the variables. So that is the use of constructor. The constructor is a special member function. It takes the same name as class name. Our class name is Q and the function name is also Q. So it is a constructor function. Other than the constructor function, we have three more functions: inserting the value into the queue, insert queue, delete queue, and display queue. So total we have four functions. The first, the queue constructor function is defined. So using constructor class template class T, the function template. So it is a class template. We included template class T, a class is declared, and it's having four functions: queue, insert queue, delete queue, and display queue. All are all four are constructor, insert queue, delete queue, and display queue. This is a template function. Again, the this function also function template. So this is a class is class template, and function also function template. Even the constructor function and other member function, insert queue, delete queue, display queue, all are function templates. So within the insert queue, what we are doing before inserting the value into the queue, we have to check whether the queue is overflow. If already there are more numbers in the queue, we cannot add any more elements. If the queue is already full, means if it reaches already, if it already reached the maximum minus 1, 0 to n minus 1 memory locations are already filled, whatever data we are going to add, that will overflow. So before adding elements into the queue, before performing the NQ, that is inserting elements into the queue, we have to check whether the queue is overflow or not. The condition for queue overflow is max minus 1. If the queue is not overflowing, then we can add elements into the queue. We will check if front is greater than rear. So it means front is greater and the rear is small. Through rear, we are adding elements, and through front, we are deleting elements. And front is here greater and rear is small, and front and rear both are equal to minus 1, means then the queue is empty. So the condition to check the queue is empty is if front and rear both are equal to minus 1, means the queue is empty. If the queue is empty, then we need, if this condition is true, as well as the front is pointing minus 1, then we will increment the front to equal to 0, then increment the rear pointer. Through the rear pointer, we are adding the element. So queue of rear, the item is added. Item is assigned to queue of rear. Get the value from the keyboard, enter the item to be inserted, see in item. Item is assigned to queue of rear is equal to item. Then the item is added. So before performing insert queue or NQ, we have to check whether the queue is full. If the queue is full, whatever element we are adding, we cannot able to add. So the queue is already overflowing, we cannot add. Then we will check whether queue and front is equal to minus 1. If queue and front both are pointing the minus 1, means the queue is empty. If the queue is empty, then increment the, or the queue is having the position of minus 1, increment the position and get the value from the keyboard, assign the item into the stack of rear, the current memory location. So the queue of rear equal to item. So this is the process of adding elements into the queue. Adding element into the queue is called insert queue, or we can say adding elements into the through the rear pointer. The next function is delete function. Any doubt in the adding elements into the queue? NQ. Any doubt in how we are adding elements into the queue? Shangat, Mahabhatra. Any doubt in adding elements into the queue? Insert queue. Any doubt in inserting element into the queue? The same way we can delete the element from the queue, that is called DQ. So the function Q template T delete of Q. So it is a function template. Function template means it can work for any type of function. So template class T void Q DQ. So within that, before deleting the elements from the queue, we have to check whether the queue is empty. If the queue is empty, we cannot delete anything. So the condition to check the queue is empty is if front equal to -1 and front is greater and rear is small. Usually through rear, we are adding the elements, and through front we are deleting the elements. So the front will always point the 0th memory location, and the rear will point the current memory location where we can add elements. If front equal to -1 and front is greater than rear, then front and rear equal to -1, then it means the queue is empty. If front and rear, the entry and exit point both are in the same location, 0th location or -1 location, then the queue is empty. If the queue is empty, nothing is there, we cannot delete anything. If the queue is not empty, then whatever element is there, that element can be deleted. Else, if the queue is not empty, you take the queue of front. Through front only, the element in the first position will be deleted first. So queue of front, the first element in the queue is assigned to item. Then we are incrementing front plus plus. Then see out item, the item is deleted successfully. So this is the function for DQ. So the function starts here and the function ends here. Any doubt? What is DQ? How we are deleting? The same way we can display the elements in the queue. Template class T. This is also a class function template. Void queue, display queue. If front equal to -1 and front is greater and rear is small. So through rear only we are adding elements, and front only we are deleting the elements. If front is in the -1 position, then front and equal to rear equal to -1 means the queue is empty. Then we cannot delete anything. There is nothing to display. If the queue is having some elements, then only we can display. Else, if the queue is not empty, then there are some elements. Then by using for loop for I equal to 0, I less than rear, I plus plus, display the elements. So the function display queue starts here and it ends here. Any doubt in display queue? DQ, NQ? So within the main program, we are declaring int main, int choice. We are getting the choice while I equal to, while I1, it means there are operations to be performed. C out, we are displaying the menu. Menu for queue operations. 1 for insert, 2 for delete, and 3 for display, 4 for exit. Enter your choice. We are getting the choice from the end user. Then, based on the choice, if the choice is 1, perform insert queue. Choice is 2, perform delete queue. Choice is 3, display the queue. Choice 4, exit from the queue. So insert queue means we are adding elements, and delete queue means we are deleting elements from the queue, and display means whatever elements are there in the queue that will be displayed. Exit means it will exit from the operation. So any doubt in this program? Any doubt what is queue and queue operations? Any doubt? Pages? Any doubt? Aryan Singh? Okay, if no more doubts, then we are entering into the next subheading called linked list. Linked list also an abstract data type. Linked list is a data structure consisting of a group of nodes which together represents a sequence. So far we were using the stack, queue, and arrays. There we are using only collection of memory locations to store the values alone. If it is linked list, it is represented in node form where we'll have data node and address node. A linked list is a data structure consisting of a group of nodes which together represent a sequence. Each node is composed of data part and a reference. So this is one node. Here we have the memory location to store the data. So this is called data node. And within the node, we have the memory location to store the address reference. Okay, in the linked list, we are taking the data along with the address. So every data is having two fields. The node is represented with two fields. One field is used to store the data. Another field is used to store the address of the next node. It's we can say it's like a train. In train, every coach is connected with the previous coach as well as the next coach. Say you was traveling in the coach number B A2. Previously, the previous coach will be A1. The next coach may be A3. So all the coaches are interconnected through some reference. The same way, the data are stored in a node form. The node is having two parts. One part is to store the value, another part is to store the address. Say here we are taking three nodes. The node one is having the place for storing the value and the place for storing the address. The node two is having the data position and the address position is pointing to next node, node 3. And the last node in the linked list is called leaf node. That leaf node will not have any address. So the node at reference position of the final node will have null address. The first node in the linked list is called header, and each node will be having its own memory location. Say the node 1 is stored in 1000th memory location, node 2 is stored in 2000, node 3 is stored in 3000 memory location. A linked list is a collection of elements called nodes, each node of which stores two items information, data part and link part. So we have the data part and the link part. The data part of each node consists of data record of an entity, the link field of the pointer, and contains the address of next node. So the link field is having the address of the next node. The beginning of the linked list is stored in the pointer termed as header node. So the first node is called head node, which points to the first node in the linked list. So the first node is called head node, that is pointing the first node, and the first node is pointing the second node. The last node is called the leaf node. The first node contains a pointer to second node. Second node contains a pointer to the third node, and so on. The last node in the linked list is next field will have the address as null. The last node is not pointing any other node because it is the last node. So the address field will be stored with null value. There are several variants of the linked list: singly linked list, circularly linked list, doubly linked list, and doubly circularly linked list. So what is a singly linked list means? The singly linked list will look like this. The node is, it is consisting of a number of nodes. Each node will have the information field or data field followed by link field or next field. The singly linked list is a collection of nodes. Each node contains two fields: the information field where the information is stored and the link field where the address or link to next node is stored. So any doubt with respect to what is linked list? What are all the terms associated with the linked list? What are all the different types of linked list? Any doubt? Any doubt? Any doubt in the concept? So now we'll see how we can represent the singly linked list using C++ coding. The operations that can be performed on singly linked list includes: we can insert node into the linked list, delete the existing node from the linked list, and we can travel through the linked list. Various operations on singly linked list are insertion of node into the list, deletion of node from the list, traversing the nodes in the linked list. The meeting will end in another 10 minutes. Okay, so if you take the C++ implementation, to represent the linked list, we are including the header file stdlib.h, iostream.h, conio.h. So we are creating the class called node. Within the class called node, we have data field and the next field. Every node is consisting of memory to store the data and the memory to store the address of next data. A node class node is created with the data field and pointer to next field, because in the pointer memory location we are going to store the address. Then a class node is created. Then we are initializing a class called list, class node and class list. So in the class list, we are having the variables like item and the address. Item will store the value, address, and head will store the address of the next memory location. Okay, class node and class list. So in the class list, we have the following member functions. Our class name is list and the function name is also list. So it is a constructor function. Other than that, we have the other functions like insert the new node in the front of the list, insert the node at the end of the list, delete the node through the front, delete the node through the end, and display the elements in the linked list, and count the number of nodes in the linked list, and delete before the position. In a particular position you delete the elements, and delete the nodes after the position. So these are all the functions we can perform with the linked list. And first we are initializing the constructor. The class name is list and the function name is list. Constructor list is initialized. So while initializing the constructor, we are assigning head equal to null. So a node is created. The newly created node is the first node. So that particular node is called the head node. So the first node what we are creating with respect to the linked list is called header node. If you create the next node, that will be a first node, second node, third node, like that. And the last node, the list is called tail node. Like tree data structure, there will be always a root. Without root, we cannot create tree. The same way, in a linked list also, there is an head node and there is a tail node. Say, for example, in trains, which is the head node, which is the tail node. So the head node and tail node are the engines. Okay, the head node is through head node is they will have the engine driver. The train will be uh, driven through the engine. The driver will be running the train, sitting in the head. And in the last tail node, there will be one person who will be having the flag. He will be raising the flag, red flag, stopping, green flag, and the person in the platform, the railway stations, various stations, they will give the signal. They will give the signal to the driver as well as the last person in the train. When the flag, red flag or green flag is posted, then only they will drive the, based on the flag from the railway station, they will drive the train. The same way in linked list also, we have an head node, we have an tail node. Any doubt? So the head node, through constructor, we are initializing each and every node. The first node what we created is head node. And now we are creating one more node. That node is added after the head node. So now we are creating, insert the new node in the front of the queue, the front of the linked list. So a new node star p is created. Enter the element to be inserted. We are getting the value for the node. C in item. P equal to new node. P points data, we are taking the item. P points next, we are taking the address. Item and address is stored in the node. If head is equal to null, then the head node is created. Then the head points to the P. Then P point next point to the head node. So we have created one node. That node is added after the head node. The same way, we can insert the node after the tail node. So there is one tail node. After the tail node, we will add the node. We are creating a node star p. So a new node is created. C in item, p equal to new node. P points data equal to item. So the item what we are getting, we are assigning in the data. P points next, we are taking the null address, because we are going to store the new node at the end of the as tail node. So we insert the node at the end. So if it is a last node, the data field will be null. That then we will check if head equal to null, then assign p equal to head. Now the new node is made as head, else node star t equal to head, where t dot next points null, because there is a head, there is one tail. You t equal to t points next and t points next equal to p. Inserted an element at the end of the linked list. So like that, we are adding an element in the end of the linked list. The same way we can delete the element from the linked list. Before deleting the element, we have to check whether the linked list is having some elements. If it's having some elements, then only we can delete. So if it's not having any elements, then the linked list is empty. So before deleting, we will check whether the linked list is empty or underflow. If it is underflow, means the list is empty. If the list is empty, we cannot delete anything. If the list is not empty, then take head points data is assigned to item, and t points head means the element t is the head node is deleted, front node is deleted, the item deleted successfully. If you want to delete the element from the end, so from the tail node, because last node the reference point will be null. Node star t star previous. If head equal to null means it is an head node as well as tail node. The list is underflow. Before deleting, we have to check whether the node is empty or not. If the node is empty, we cannot do the perform. So we'll check the underflow condition. Then if it is having some elements, then head points next is assigned to null. So that particular is the particular element's address location is pointed as null. Then that element is removed. T points data is deleted successfully from the node. Else, if there are other elements, the tail element should be deleted. So we'll make it as previous equal to t equal to t points next. Then p points previous node next is assigned as null. So here we want to delete the element from the end. Last none element should be deleted. We will check whether the element we are checking is a head node as well as tail node. If it is head node and tail node, both will be deleted. And delete the element in the particular position. We will get the position value. With respect to the position, we will check whether the position is less than the size of the list. If the size of the list is more and the position is less, then only we can perform. If the list is empty and we are getting the position, means the position is not existing in the list. We'll get the position, then we will assign, we will find out the count, number of coaches, number of list in the linked list, number of nodes in the linked list. That node count is retrieved. Then we will check whether the position is greater than the node count and position is not equal to 0. If there are some elements and the position is existing, then the particular position is deleted. How we are deleting means, while I is less than position, the t is assigned to previous, t points next is assigned to t I plus plus. So the particular element is removed from the linked list. The same way, delete a node after the position, we will get the position value. After getting the position value, we want to check whether the linked list is empty or not. If the linked list is empty, a head equal to null means it is empty. The list is underflow. We cannot delete the element. Else, we will get the position. We will check the position. Then we will get the node count. How many nodes are there in the linked list? Node count is stored in NC. Then we will check whether the node count is greater than the position. Then if the node count is greater than the position, the node is not existing in the linked list and the position is less than or equal to 0. The position what we are reading should not be less than 0, as well as we should not exceed the number of elements in the list. If the condition is true, if both the conditions are true, then we will delete the then we will delete, we'll go to the particular location, I is less than position, because we want to delete the element which is less the previous element of the position. Take t equal to previous and t equal to t dot next and I plus plus. So the particular element is deleted.